Hello and welcome back. This video will be about Corynebacterium diphtheria and Listeria monocytogenes. So I might not have enough time to get onto Listeria, so I will make this part 1. Okay, as always, please leave a comment or like if you enjoyed the video. Okay, so some key words and some high yield points just to start off. Well, Corynebacterium is a gram-positive bacillus and it's a non-spore forming type. So the key facts here and the key words here are this. So for Corynebacterium, they're going to be on the left-hand side and include metachromatic granules, ribosylation, pseudomembranous exudate, and for this I've got PPP because you could describe the pseudomembranous exudate on the posterior aspect of the pharynx. And these words, they might sound complicated, but once we go through this topic, it will be very simple and easy to understand. And of course, the bull neck, clinical feature that is very typical for Corynebacterium. Okay, Listeria monocytogenes, it's gram-positive bacillus, motile and facultative intracellular, as well as actin motility for intracellular. So what that means, I will simplify it, but it's something called like actin rocket motility. It's kind of like the movement of the actin filaments that allows it to go straight, the bacteria to go straight from one cell to another. I promise it will make a lot more sense. And tumbling motility. Okay, so gram-positive rods and Corynebacterium and Listeria. So what do they have in common? Well, both these gram-positive rods infect patients in the pediatric age group. And Corynebacterium diphtheria especially, you need to understand this very, very well. It colonizes the pharynx and forms a grayish pseudomembrane. And it's a pseudomembrane because it's not a true membrane. It's kind of like fibrin and kind of like Corynebacterium cells that are being deposited. So from this site, the bacteria releases a powerful exotoxin into the bloodstream, which specifically can damage the heart and the neural cells by interfering with protein synthesis. And the mechanism we will go into, it will be very easy to understand. So where the metachromatic granules come in is that the club-shaped appearance of the bacteria is due to pockets of these inorganic phosphates. So the Corynebacterium, yes, it's gram-positive, yes, it's a rod, but the shape that it makes under gram stain and under the microscope is in fact club-shaped, and which when stained form these metachromatic granules. And the interesting thing is, actually, let me just provide you with a little bit of a differential. Metachromatic granules are not just typical for Corynebacterium diphtheria, but also for Pseudomonas. And what I should have also included, actually, is that while Corynebacterium diphtheria is a gram-positive rod, Pseudomonas, which also produces metachromatic granules, is a gram-negative rod. So in the question stem, when you get asked about a gram-positive rod with metachromatic granules, because you know they said gram-positive, it's going to be Corynebacterium diphtheria. If they had said a gram-negative rod, it would be Pseudomonas. And also, Corynebacterium is often used on tellurite agar, and blue-red colors formed. So morphology and transmission. Well, okay, this is one of our kind of more simpler transmissions. It's gram-positive rods. These are pleomorphic and club-shaped. Actually, if you look at the image on the bottom, which I've got from this website, they are arranged at acute angles or parallel to each other, making them look like Chinese letters. Okay, that's one of the kind of hallmark features, Chinese letters appearance of C. diphtheria. These are non-spore forming and non-motile, and their route of transmission is respiratory droplets from the carrier. Metabolism. Okay, 2 simple points. These are facultative anaerobes and catalase positive, meaning they form bubbles and they're able to make H2O from, Okay, so where does it live? Where can you even find Corynebacterium diphtheria? How does it infect? Okay, we said it's by respiratory droplets. Well, initially, these are the key concepts. Initially, it is not a systemic infection. The bacteria itself will remain in the respiratory tract. And in fact, I have an image later on of where we look at that pseudomembrane. And if a pediatrician or a doctor tries to remove that pseudomembrane, that is what will cause kind of more and more toxin to be released into the bloodstream. So yeah, it will stay in the respiratory tract, but then how does it cause pathogenesis? Well, it will start to make the toxin. The toxin will then enter the circulation, and that's how the toxin is what primarily causes the clinical features that are associated with Corynebacterium diphtheria. So think of the respiratory tract as Corynebacterium diphtheria's house, its home, and from there it does more things. Okay, so what's the virulence like? Okay, well, the pseudomembrane will form in the posterior pharynx, PPP, remember that, it helps. And this actually serves as like a military base from where it will send off its soldiers to go and attack the army, go attack the enemy. So it really serves as a base, and the toxin would then be the soldier that leaves the military base. Here is a picture of your pseudomembrane. Now, if you as a doctor try and scrape that out, that will harm the situation more than it will do any good. Okay, the pseudomembrane can cause lymphadenopathy and eventual airway obstruction. Thickening of the neck is referred to as a bull's neck. And here is exactly the same slide, but with the bull's neck picture over here. You can see the visual abnormal enlargement of the thickening of the neck as well. Okay, finally, onto pathogenesis, of Corynebacterium diphtheria. Okay, this looks like a complicated diagram, but you need to understand that the bacterium itself will remain in the respiratory tract. Yes, okay, good. Then it will produce the toxin, and the toxin will then travel around through the circulation, and eventually, the way it will cause all of those clinical features we're about to discuss, as well as the pseudomembrane, it leads to protein synthesis inhibition and cell death. You might ask how, and I will tell you how. But before that, let's look at the toxin. So, the toxin has 2 subunits. The toxin will enter through receptor-mediated endocytosis, and here there are 2 subunits of the toxin. A is for the active unit and B is for the binding unit. So the B component of the toxin actually attaches to the cell receptor, and after that A will dissociate from B. So once again, A and B are 2 subunits of the same toxin. A for active, B for binding. Remember it that way. B will bind, A will dissociate, A will enter the host cytoplasm, and then it does this thing. It will actually inactivate elongation factor 2. So here's where our keywords are coming into play yet again. Ribosylation of the elongation factor 2 will then inhibit protein synthesis, okay? You don't really need to know how, but let's say ribosylation or ADP ribosylation of the elongation factor will then inhibit protein synthesis.
It's 21 hours.
Leading to cell death. Sorry for that. Okay, so what is it doing within the human body? Okay, the pathogen is going to enter via the nasal passages or even inhaling because it's a respiratory droplet. It will then cause pharyngitis, pseudomembrane, or obstruction. Remember, the pseudomembrane can thicken so much that it becomes an actual airway obstruction, okay? And then if you look at number 5 and 6, those are your key points. It can cause toxic peripheral neuropathy, myocarditis as well. So it starts with a mild sore throat with fever initially, pseudomembrane, of course. And by now you should drill into your head pseudomembrane on the pharynx in diphtheria. Myocarditis will be in 10% of patients. And the neural involvement, okay, this toxin can actually damage the myelin sheath of nerves and cause symptoms like peripheral nerve palsies. Treatment? All right, we're finally on to the treatment. Antitoxin. However, there's some debate about whether this is an actual treatment or not, but penicillin or antitoxin was what I'm referring to. Then penicillin or erythromycin, and of course, you might have heard of the vaccine, DPT, diphtheria, pertussis, and tetanus. Okay, that's it for now. I will come back with a part 2 on listeria. Please like, comment, and subscribe if this was useful for you, and thank you for watching.